problem 1524 and 1522 diameter of N-Ary tree. So this is similar like the Leetcode problem 1245 diameter tree. This is just it is set at N-Ary tree. Actually, the data structure is also different. So we are just giving a node. So inside of the node, basically we have a value, and also we have a self.children. And for the self.children inside, it is an array. So if the children is not noun, yeah, so it will be a children. So inside of the children inside the array, it will be a number of a child node. And if there's no children, so it's gonna be an empty array. So this is the data structure, and this is the only difference. And what we're gonna return, we're gonna return the diameter. It's also the same. So for this example, the diameter is 3. So the maximum path is from 5, 3, 1, and 2. So the length is 3. And we also need to know the N-Ary tree structure. So this data structure is just from the root node to the leaf. So this means it is directed. We don't need to deal with the undirected situation. So now let's try to solve the problem. Basically, it's the same like tree diameter problem. So we're gonna prepare a global variable self.result. It is 0, and then I'm gonna design a DFS function. So inside the DFS, let me put a node, because this kind of a data structure, it's a tree node. So inside, I'm gonna put a node. So this node actually will be the root. So finally, I'm gonna call the DFS function and put a root inside and return the self.result. And inside the DFS, basically, it's the same. And this time, I'm not gonna prepare a parent to check if it is visited or not, because this is not a graph and it is directed, it is a tree structure. So I don't need to check the visited node. So I just need to prepare a variable. I'm gonna define a variable first. So start from 0. So this first means the longest path starting from my root node. Yeah, so for example, this is the root node, so the longest path is 2 currently. And then I'm gonna use the DFS function to check the longest path. So the first will be updated to the maximum. Yeah, because the first is the longest path. So for child in, yeah, let's say we have the data structure of this node. So let's say, so yeah, so for child in not dot value and not dot children. So not dot children is an array. So let's check if the children exist. If it's not exist, so the child, there's no child. Yeah, so it means if the child exists, what are we gonna do? We're gonna update the result. So we're gonna prepare a second longest variable. So this second longest variable would be updated to the DFS with child plus 1. And then I'm gonna prepare the global variable. The self.result would be the max of self.result with the first plus the second. Now I'm gonna update my longest. So the longest would be the max with the first and second. And the return would be the first. Yeah, so this function basically means the DFS function basically means for each node, what is my longest path? Because I always return the longest. From the beginning, the longest is 0, because I don't know if there's any children with it. So for node 1, it has 3 children, but the longest it is 2. So this first will be 2. For example, for this for the first bronze, it will be updated to 2. And then I'm gonna also check the second longest. So for this node 1, the second longest is still 1. So the final result would be 2 plus 1. It's gonna be 3. Yeah. So basically, this is the entire code. Because I don't need to check the parent, I don't need to check the visited node, because this is a tree structure and it is a directed graph, so I don't need to go back. Yeah, and it is also a tree. It's not a graph, it is a tree, directed tree. So I don't need to check if this node is visited or not, because I only need to check it just needed to go down for the DFS function. Now let me run it to check if it is okay. Yeah, as you can see, it works. Now let me submit it to check if it can pass all the testing cases. As you can see, it passed all the testing cases and it's 98%. And the time complexity is still ON, because no matter how many nodes, it is only like a tree traversal. But this tree traversal, basically, it likes a post-order traversal. Yeah, so for this node 1, it's gonna check all the node first before it goes to this node 1. It is a DFS function, and so the time complexity is ON. Thank you for watching. See you next time.